After the short video on absolute values, we are going to cover a little bit inequalities, and we cannot study inequalities without looking at the number line. So if you look at the number line here, we have the 0 here, and the left of the 0 and the right of the 0. This is really for the low level, low classes, but to understand our equations later we need this. So if we have a number located like on the left of the 0, it is a negative numbers, and the other side of the 0 is positive. Okay, so we have to know that, because it's going to count shortly. Now if we say 5 less than x being a number, you can also write x greater than 5. So if you look at the number line here, I can show you what that means. Okay, if you look at the graph here, it is numbers strictly greater than 5. Okay, we have a hollow circle here showing that everything on the right side of the 5 but excluding 5 is part of this solution. So all numbers greater than 5 okay, so you have to understand this, because this is the basics of these graphings. So suppose now that I have an equation showing x greater than or equal to 5. Let's see how we represent that. Okay, so if you look at our graph now, this area here, let me change the color. This guy here now is a full circle showing that this 5 is also included. So any number that is at least 5. Okay, this is how we note it. At least, or it means greater than or equal to 5. Okay, now let's continue. We have another situation when we have all the values less than or equal to 2. We can call that no more than 2, correct? No more than -2, for instance. We can say x less than or equal to -2. So if you look at our representation here, we have the -2 here, and all the values on the left up to -infinity, wherever it is, are included in this solution. So the value, any value that is not more than -2 is the solution. I hope you understand this. Now since we have these basics, we are going to expand it. Okay, Now let's do some practice here. Okay, so if we take, let's say here, practice. If we have to say 5 minus 2 times a number is greater than the opposite of 4. So let's go. 5 minus 2 times a number x, for instance. 2 times a number is greater than the opposite of 4. There you go. Okay, so let's take another one. 3 times a number x, 3 times x, minus 7 is less than or equal to the opposite of 10. Is less than or equal to the opposite of 10. There you go. Okay, so let's take another one. When I say 4 times a number is at least 2. Okay, if a number is x, 4 times a number is at least 2. Is either 2 or greater than 2, correct? So greater than or equal to 2. This is how we translate this. Okay, let me write something here and let's try to say it. If we try to say this one, we can say 1/3 of the opposite of a number is less than 12, correct? A number increased by 5 is less than 7. We can say x increased by 5 is less than 7. Okay, and we can also say 10 less than a number is more than 30. 10 less than a number, the number minus 10, is more than 30, greater than 30. Okay, let's continue. So if we try to continue here, we can say like 6 less than 2 times a number is no more than 17. 6 less than 2 times a number. If number is x, so 2x minus 6 is no more than 17. So it can be 17 but cannot be more than 17, correct? So less than or equal to 17. Okay, so far we have seen greater than or equal to, less than or equal to, or equal to. So we are going to deal with these during our equation solving. Okay, so if we have the following, I'm going to put this one in different color because we cannot proceed in solving equations involving inequalities without knowing the following. Okay, so if I have x less than y and another number u, okay, positive here or negative, whatever, that matter, So if we say x plus u, it will be less than y plus u. Okay, this is addition property. You have to remember this one. Okay, so for the next one, we have a very important property. People miss this one when we multiply by -1. So if I say x is greater than y, what do you think -x compared to -y? Remember, if you take the absolute value of these, it will be very interesting to see. Now we are coming from 0 to this side, and from 0 to that side. If we have x here and y here, that means, let me change it here to match what we are trying to show. So if we have y here and x here, x is greater than y, so this is what we have here. So if we come this side, on the negative side, guess what? What do you think of this situation? We have -x here further on the left now. That means -y is greater. Okay, so that means -x is less than -y. This is a very, very important property. I'm going to strike it home again. You have to know that when we multiply an equality by -1, we flip the sign. So if x is greater than or equal to y, -x is less than or equal to y. Remember that, and we will be fine in the next video for solving these equations. Okay, to take this further, we have to say this: if we multiplied or divided by the same negative number, the equality symbol is reversed. So if I have x and y, if I divide them by -n and by -n here, if only originally x is greater than y, so minus x over n compared to minus y over n, this is reversed, so it becomes less here. Interesting. And when we say also x is greater than y, when we take the reciprocal 1 over x compared to 1 over y, is again reversed. So these two should be remembered when we are working on these equations. Okay, so that's what I wanted to add here, and we will solve these and graph them, and it will be in the next video. Thank you.